Well, I'm not the deepest expert, but indeed, intoPIX is doing a lot of stuff linked to compression. This presentation is really about introducing everyone to the key benefits of JPEG XS for live production workflows and what JPEG XS brings in terms of efficiency, to reduce bandwidth, but also operating costs or really the live production workflow installs. We hope this presentation will enable you to discover how you can use JPEG XS, but also how you can integrate it in several types of IP workflows. As you are at NAB, I encourage you to go on the show floors, and you can discover this year more than 100 plus products supporting JPEG XS from 50 plus manufacturers on the show floor, which is a good testimonial of the current acceleration that the broadcast industry is doing on adopting it. So first about JPEG XS itself. So it's the first time the industry is creating a codec with really a different purpose and that purpose is to replace uncompressed video in mind, but by preserving an extremely low latency, an extremely high quality, and with extremely low complexity. So all the values that broadcasters like when working with SDI today, that it's uncompressed, that it's reliable, that everything can be synchronized, that the low latency is there, are a part of the main value of JPEG XS. And that's what makes it very different from previous compression technology, other compression technology that you know. So the key benefits in a nutshell, so it's visually lossless quality, so I will speak a bit about that. Constant quality, so after multiple encode, decode, to preserve the quality of the video flow. Extremely low power, low complexity, and high speed. So if you are on a various platforms, whether it's a CPU, a GPU, an FPGA, or even an ASIC, this algorithm has been designed to scale perfectly to always be efficient. So if it's an FPGA, efficient in power consumption. So we want a codec that reduce the overall power consumption also of a broadcast facility by using JPEG XS. A CPU that can run real-time HD and 4K easily in commonly used CPU processor. Also no latency. When we speak about no latency, you can walk on the show floor, you will see a lot of bushing, no latency, but then you have to ask. Some people will say, oh, I mean 100 milliseconds. No, with JPEG XS, when we say no latency, we go with less than few, I would say 24 video lines or some, depending on the implementation. If it's FPGA based or CPU or GPU, it may vary, but it's a line-based compression. So you could encode in an FPGA, for example, with only 100 microseconds of latency of video stream. This is less than 1 millisecond. This is equivalent to an uncompressed video stream today. Scalability, multi-resolution support. This compression technology, as for example JPEG 2000, or if you know Cineform or VC2, is based on wavelet coding. So it's not using the traditional DCT transform that you have in a legacy JPEG or MPEG-2 H.264 HEVC, that when you compress too much, you could have blocking artifact. With wavelet, it's work with frequency, and this is really the way your eyes are perceiving an image today. We are very good on not noticing artifacts that are generated by wavelet codecs. So this is a key benefit of using wavelet transform for that compression. And also, this is an ISO standard. So you have other codecs today in the market, like you can take a NDI codec, you can take a proprietary codecs like a ProRes from Apple, DNX HD. Here you have an ISO standard that has published specification that can be implemented by anyone as an open specification. Which is also important for this industry that want to move to open specification in what they are doing. For interoperability, of course, that's also important. So the initial goal of JPEG XS were to reach the lossless quality, reach ultra-low latency, but also when we created the JPEG XS standard, we put the bar on the complexity. It's the first time in the history of video compression that we say, we want a proposal for compression that can be real-time for 4K in a i7 processor. That was in 2017, so on the 8th generation of Intel processor. Now we are on the 12th, I think, so they get faster and faster, but already at that time, 4K 60 was achieved. And also on FPGA, we look at the low-cost, low-power FPGA from Xilinx, Altera. At that time, we said it should not exceed that footprint, that size, because for the industry, it's also cost-sensitive to promote a compression that can be efficiently integrated in any Ethernet port of a production workflow. So that's a key benefit of JPEG XS. So about the quality. So I said lossless quality, visually lossless quality. What do I mean when I say that? So we want an accurate reproduction of the source. For JPEG XS, the standard has been using for the first time a new method that is an ISO standard that's called a near lossless quality assessment on both natural and synthetic images. So the ISO IEC 2090-170-2. This is a test that we do. We did that with 360 people looking at the various type of contents where one side of the screen has been compressed, but several times. So to test the cascading effect and that it was robust in quality. The other side is uncompressed. And what we do is we alternate uncompressed images with the compressed one. And we ask the audience, can you notify which side of the screen is the compressed one? And so we perform these tests, testing various compression ratio going down to 10:1 to qualify that the JPEG XS codec was transparently lossless, I would say, on the test content that were selected at that time. With further evolution of JPEG XS, I will speak about how JPEG XS is also future-proof. We now have a new generation of JPEG XS profile arriving this year that can even push the bar further, essentially on screen content, gaming content, desktop content, to compress even more. So in a nutshell, with what I just said on the previous slides, JPEG XS, this is not a codec. You have to think that this codec is made for the people that will tell you, I don't want to hear about compression. This is really the mindset of that codec. And this is really to replace uncompressed video by combining the best speed, the lowest complexity, the highest quality in a single codec. So you see in this diagram how different JPEG XS is from the traditional codec. So you see intra-frame codec like JPEG, JPEG 2000, AV Sintra, ProRes, or distribution, I would say internet codec like H.264, HEVC. These codecs have been more focusing on the compression efficiency at the cost of more latency, more computing in software, more power consumption. JPEG XS cannot compress as much as this codec can do. It compresses less, but it preserves the latency, the quality. It can compute efficiently on any platform, and it offers a low complexity. You see the JPEG XS high profile. That's what is being massively used today in the industry. And you see the JPEG XS TDC profile that's upcoming, and that has been essentially focusing on improving the compression technology to go one step further. So what does it mean in terms of bandwidth range? So of course, it will depend on your workflow. It will depend on the type of production. Is it the Olympics? Is it the Super Bowl? Or is it just a remote viewing with extremely low latency just to make the right decision about the primary stream that you want to broadcast? You have a lot of value in JPEG XS. The first one being the extremely low latency that you get to make the right decision during your production. And the second one is replacing the uncompressed video. So in this range, what we are showing is the typical range that you have with uncompressed video. This is, of course, massively high. If you look at 4K and 8K, it doesn't sound reasonable. It's not the way you will democratize and push a 4K workflow in the production. With JPEG XS, everything can go over Ethernet cables. You don't need fiber. You can go over Cat5, Cat6 cables, 10 gig, 2.5 gig, 1 gig ports. You have much more flexibility. Moreover, JPEG XS also offers scalability thanks to the wavelets, so it's possible also to further optimize the network. I show you concrete example of that last benefit. So thanks to the wavelet, for example, on my encoder side, so if you look at the left side, I can capture a 4K stream and I can at the same time generate without any impact on latency a preview stream that will be 1K resolution, for example, running at 40 megabits per second on my network, and a 500 megabits 4K stream that could be my master stream. In my network, I could have, with, for example, if you know NMOS device subscribing to either the preview stream or the master stream. They all have the same latency, and I can further optimize my network capabilities by, instead of subscribing to all the video stream that is available, just subscribing to a preview 1K stream. So this is interesting for preview proxy stream, but also the scalability that you have on the decoder side allow you that to receive, for example, a 4K stream or HD stream and to only decode a sub resolution. I can decode HD from a 4K stream. I can decode 1K from a 4K stream. And this enable you to create better workflow that will use less computing power on your workstation, on your servers, that will also reduce the bandwidth overall with the promise of extremely high quality and extremely low latency. So now in the industry, where do we leverage JPEG XS? So you can really consider that JPEG XS as being a new SDI support for both 2110-22 or 2022-2. These are additional acronyms. I will speak about them later on. We have so many acronyms in this industry, that's crazy. So effectively, JPEG XS enabled to bridge the local area network, the studios, the TV facilities, to a wide area network, on even to the cloud if you want. So traditionally on premise, people will use FPGA-based JPEG XS codec, for example, but for cloud workflow, they will leverage JPEG XS directly in the cloud. So for example, AWS offer JPEG XS support with CDI, if you're familiar with that. So JPEG XS goes into 2110 workflows, into remote production, and in any latency critical application. It's also an efficient path to 4K, 8K. You saw the type of bitrate that can be targeted and what it enables for workstation, server, and Ethernet interfaces. So the diagram here summarizes in a nutshell the type of standards that can be leveraged for the transmission using JPEG XS. So JPEG XS can be transported over RTP or over transfer stream. And if you do that over RTP, it can be directly leveraged within the SMPTE 2110 ecosystem, the same way as you leverage a non-compressed video stream. You have compressed video stream into the workflow, but it can also be leveraged with the upcoming IPMX standard that is standard also promoted by the VSF for intra-facility that doesn't rely on the PTP synchronization, for example. You can also leverage with RTP GCCG, which is ground to cloud to cloud to ground. So how do you move your workflows to the cloud to build live cloud-based production? JPEG XS in transfer stream can be also applied to GCCG, but on top. It's essentially used for wide area network contribution link, where you can apply FEC. You can put all your essence, audio, video all together, keep them in sync over your wide area network. So I illustrated some application that we see today with JPEG XS. So essentially, remote production. You want to connect the stadium, the venues to your facilities. You want to connect the OB-WAN to the venues, to the facilities. All together, you can use JPEG XS. Within the OB-WAN, to go to a cost-effective switch to a simpler cabling, it can be leveraged, or I would say in local area network as well. It's also being used for remote video assistant referee, as you have extremely low latency. If you have multiple games at the same time, you can have the VAR, the people that are outside the stadiums, and that they can be called on distance to do their referee job and connecting to multiple games at the same time. So it helps to centralize the effort as well with extremely low latency to provide the decision of the referee. In TV facilities and studios, obviously, that want to connect together, or that want to connect buildings even, or studio, even the same buildings. In virtual production, you have examples like the Red camera, for example, that output directly 2110 JPEG XS stream, but you have a camera that needs to be kept in sync with the LED wall to work at the same frequency, so that they can create that virtual production. JPEG XS enabled to use a 10 gig for 4K, or and a Cat5e or Cat6 cable instead of a fiber at that level, or offer more flexibility. Remote post-production, color grading. JPEG XS support 444, 12-bit, HDR, remote color grading, remote color in a post-production is a common thing. So with JPEG XS, you have the cinema quality that you need if you need to do that remotely, and the efficiency of the low latency. And live cloud production, that's a big trend. More and more big events are moving or to cloud production, so as a way to extend their capabilities. That was used at a bit test at the previous Olympics. It will be more common in the next Olympic Games as well. Cloud production is there, and JPEG XS is a way to bring your feeds to the cloud, get them back, but also if you have different VM that you want to connect together efficiently, JPEG XS is a way to do that as well. So now the acronyms, the numbers, and the details. So the presentation will be available on the internet afterwards, but this is a kind of a summary of all the standards surrounding JPEG XS. So if you want to deploy it, of course, you need to pick the right one for the right application. So, of course, about the compression, everything gets defined at the JPEG committee at the ISO. So you have the -1, 2, 3, 4, 5. So the coding, the JPEG XS profiles, the container, or do you do the HDR signaling, for example, but also the conformance testing. So you have with JPEG XS a constant bitrate codec. We have a fixed latency model so that everything gets predictable when you use it. And you have a reference software that's available on JPEG website. intoPIX is also providing access to its own reference software, slightly better in quality. If you want to test JPEG XS, you can ask also a reference software. On streaming efficiently over LAN 1 cloud, you have the RTP payload that has been defined at the IETF. The reference is there, but you have the SMPTE 2110-22. So you know that in 2110 you have a -10, -20, 21, 22, 30, 40, 41, etc. So the -22 is about compressed video payload that you use in the system. It doesn't change anything in the system for like an NMOS controller. It's a source as the others. And I will speak about NMOS later on. It's also done. So the RTP will be used with the IPMX, with the 2110 and the GCCG specification. So you see some VSF recommendation, like, oh, I have a pointer. It's excellent. Does it work? No, it doesn't work on the screen, but so on this specification, so you can read the TR11 for ground to cloud communication. That one, you can use JPEG XS either on 2110 for ground to cloud or even with a transport stream as well. So relying on the TR07, which explain how do you build interoperability with JPEG XS over 2022-2, so which is the transport stream transport with FEC, forward error correction. So typically wider network communication or contribution link. So you have also other stuff. So we are in the broadcast industry, but if you look around, for example, in virtual production, a lot of people are now looking at set using multiple cameras. They often rely on industrial vision cameras that rely on, you probably know, GigiVision or USB Vision or Co-Express. I don't know if you're familiar with this kind of standard, but even JPEG XS has been standardized within the GeniCam, which is the payload that is being used in machine vision. So if you build a workflow with machine vision camera, like motion capture things with a grid of cameras, you can use JPEG XS in this kind of workflow as well. So NMOS protocol, discovery, registration, management, with JPEG XS, it's all there. So the same way you recognize your audio feeds, your uncompressed video feeds, you will see it appearing in your controller as a JPEG XS source. You get the resolution, the colorimetry information. Everything has been done and tested by interoperability test in collaboration with VSF, but also some industrial that did organize some tests. I'm getting to the end, sorry. And for at the end, storage, edit, MXF, MP4, everything is done for that. So it's future-proof. Any resolution, any chroma sampling, 444, 422, 420, even raw Bayer from camera can be used with XS. It's up to 16-bit. HDR is support. There is no limit in frame rate. So today, creativity will bring you to any kind of format, and that's the promise of moving to IP with SMPTE 2110. JPEG XS is aligned with that value. And scalability, I presented you the powerful scalability you can leverage to send your stream or to receive. Thanks. So, and delivery management, some people are even trying or using JPEG XS with SRT, ZXI, or RIST, even it's not the primary purpose, as this format usually had additional latency. So I will rush a bit because otherwise I will be out of time. But I just want to continue on the future-proof and I would say revolution. So you know JPEG for a while. For the first time within the JPEG committee, we created a codec that is not just intra-frame. The new TDC profile is a codec that is mixing intra-frame coding with inter-frame coding within the wavelet domain. So it's complete blue ocean strategy that you don't see in any other codec. So meaning that in my video frame, my video stream, I can leverage the fact that I may have some redundancy with the previous frames. When we do that, we still preserve the low latency quality of JPEG XS. So I have no impact on the latency by moving to interframe. So I still have the promise of 1 millisecond to compress, but I can, as indicated here, get 50% more efficiency on some screen content stream or gaming content where I have more redundancy, like a fixed background with only myself moving here. I would be able to compress more, for example. It's used wavelet prediction, so it's nothing similar to like MPEG traditional codec. It keeps the complexity low. It delivers ultra low latency. It's also optimized to preserve extremely low power consumption, the promise of JPEG XS, by even having an embedded compression within the compression itself, so that if we use memories during the coding, we can use less memory than an original codec. So I put few PSNR graphs here, and you will see that, for example, on natural content where everything is moving, the high profile and the TDC profile behave the same. But if I have, for example, here a static position of my camera, where I have only the waterfall in the middle that's moving, I get a big jump in PSNR, meaning that I will be able to compress more in this kind of context or increase the quality of JPEG XS further. So this is a new innovation from the JPEG committee as well. So something else for gaming, esport content. You see also here I have some static natural content. I have a big jump. And if you're familiar with PSNR curves, when you get 1 dB, this is a lot. Here we move from 55 to 57. This is very impressive. I show you that on screen content and desktop. So here you have some video moving. You may be familiar with this kind of content. It's also used in HEVC testing. For example, we have a big jump here. I start on that content. I would be at 30 dB, but I rapidly rise up to 50 or 60 dB. So I have a significant increment in quality moving to a TDC profile with this kind of content. So we are reaching the end of the presentation. As a conclusion, I would say that JPEG XS deliver growing benefits in terms of low latency, low complexity, quality, features, software, hardware operation to improve media workflow. So today it's being used in premium quality contribution and production application. At intoPIX, we believe that it could really enable to bring more cost effectiveness in any IP media workflow. It's replacing uncompressed video and JPEG 2000 in many applications. It's helping to bridge the migration from SDI to IP thanks to its efficiency. And it's been specified to be flexible, scalable, and future-proof. And I invite you to check all the vendor solutions that are being presented this year at the show. Questions?
Thank you very much. Do we have any questions?